I'd like to just briefly talk about pros and cons of designed experiments. Again, this isn't a big part of the course, but it is something I'd like to discuss. So some pros of designed experiments is that you can have more reliable results. And that's because you can have more control. So if I'm going to run an experiment, I can control a lot more than if I'm just going to do an observational study. So we can control for some of those confounding variables. So there's more reliable results. You can control for some, I don't want to say all, but some confounding variables. So you can think about what other variables might get in the way of your results. You can kind of control for those. And you can show causation. So the easiest example I can think of this is cancer research. If they could run an experiment, then they can show that this medicine causes this to happen, or this treatment causes that to happen, or this input causes this output. So you can be a little bit more bold in your statements if you can have more reliable results and more control. So you can show that causation, whereas in observational studies you can't. But in the designed experiment, if you do it correctly, you can show that causation. Some cons to designed experiments is that they're more expensive, usually much more expensive, and again, that's including time and money and people. It takes more time to design the experiment, it takes more money to run the experiment, it takes more people to make sure the experiment goes smoothly. So you have the planning, the design, the implementation, and the analysis, and all of that takes a lot more time. To plan, design, implement, analyze, that whole process is more expensive for time, money, and people. And sometimes you cannot do an experiment. So it's sometimes impossible or impractical. I don't know if I spelled that correctly, but we'll pretend like I did. It could also be harmful sometimes. And so if we're trying to study smoking habits, I can't force someone to smoke. If I'm trying to study cancer, I can't give someone cancer. So sometimes it's harmful, and you just can't do an experiment. You just have to wait and study what happens. So sometimes it's not possible to do designed experiments. So that's just a little bit about the difference between observational studies and experiments. Your book gets into different types of observational studies. Again, I'd just like you to read that on your own time. There might be a homework question about the different types of observational studies. We don't get into this. It will not be assessed. But I do want you to be aware that there's different ways to run studies. So that's about it for 1.2. It's a pretty short section. So now we're going to get into 1.3, and we're going to talk about a census versus a sample. So a census is collecting data for an entire population. So trying to get every single individual in the population's information. So if I'm going to collect data about Lone Star students, it would be me trying to go ask every single Lone Star student whatever question I'm trying to ask. If we're trying to collect data about animals, it's trying to get every single animal in data's collected. So what I'd like you to do, normally that sounds like it'd be great. If I could ask every single student, I would have these amazing results that would represent the entire population. So the question is, how good is the census? How reliable is the census? And so what I would like you to do, the directions say, printed below is a story which can be used to demonstrate the effectiveness of a census. Assume that the letter G, capital G or lowercase g, is what we call a defective product caused by some gremlin. This is just kind of a silly story. and you're the inspector. So what you're going to do is allow yourself about 3 minutes to count all the uppercase or lowercase g's in the story below, and place your total at the bottom of the story. So what you're going to do is pause the video, set a timer on your phone or just kind of look at a clock. Give yourself about 3 minutes to read through the story, and you're going to count how many g's you find, capital or lowercase, how many g's you find throughout the story. And then I want you to write your total here at the bottom. So again, pause the video, go through the story once or twice, count up how many g's you find, and write your total here. Okay, so hopefully you've had a chance to do that for yourself. Your total, I've gotten numbers in the 60s, numbers in the 70s, numbers in the 80s. I've had numbers in the 90s before. When I do this in a classroom of 30 students, everyone's total seems to be different. I have very few totals that are the same. So more often than not, the total you wrote down is wrong. And that's kind of shocking. It was a very simple task. But most likely the number you wrote down is wrong. There are actually 83 g's in the story. So that's kind of scary that counting up g's, a simple task, most of the time that total is wrong. So what does that show? What that shows is that trying to get data for an entire population is tedious. That was probably a very annoying task. And it's also inaccurate, which is kind of surprising. I tried to do a very simple task, and more likely than not, you might have gotten it wrong. So trying to collect data for an entire population is exhausting, and it's inaccurate. So instead of trying to get a census, we get samples. So that's why this course is called Statistics, because we base all of our data off of samples. All the numbers we come up with are from samples, not the entire population. So section 1.3 in your book is about taking a simple random sample. This is the easiest way to get a sample. It's abbreviated SRS. We're going to see simple random samples throughout the rest of the course. And so I'm going to teach you how to take a simple random sample. The first thing you have to do is enumerate the population. Each individual needs a unique number, and this is called a frame. So we all have driver's license numbers. We might have social security numbers. You have a Lone Star ID number. You have numbers to refer to yourself. So each individual gets a unique number, and we call this a frame. And we select so many numbers from the random digit table, which we're going to go over how to use that in just a minute. This lowercase letter n is what we call our sample size. So maybe I want a sample of 5, or a sample of 10, or a sample of 20. So that sample size is lowercase n. And we're going to see that again throughout the rest of the course. Anytime you have a lowercase n, that is referred to as your sample size. And you can sample without replacement, where we ignore repeats, or with replacement, where we include repeats. For this course, again, I don't like to say always, but most of the time we are going to sample without replacement. So if we have a repeat, we are going to ignore it. All right, so here's an example. We're going to do a couple examples of using the random digit table. This is simple, but students get a little confused by it. So don't feel bad if you're a little confused. On the homework, it's even more confusing because it's a digital homework. So I'm going to do my best to explain it here. But feel free to email me if you're a little lost on how to collect a random sample. So we have a list of 30 companies, and this is our population, all 30 companies. And our job is to get a sample of 5 from this list of 30. You'll notice that each company's name has a number next to it. This is 01, 02, 03, all the way down to 30. Notice every company's number has 2 digits, so even 987 is 090807. So if you have more than 10 in your sample, you have to have a 2-digit number associated with each person. So if one has a 2-digit, everybody's got to have 2 digits. So you'll kind of see a guide down here. If there are 10 or less in the population, you can use the digits 0 through 9, single digits. If there are over 10 in the population, you use 0, 1 to 99, depending on how many you need. If there are over 100 in the population, you need 0, 0, 1 to 999. And if there are over 1,000 in the population, you have to use 0, 0, 0, 1 to 9999. So the biggest number determines how many digits everybody has to have. So that's the first thing that hopefully to pick up on is depending on how many you have in your population, you either use 4 digits, 3 digits, 2 digits, or 1. And whatever number you choose, everybody has to have that same amount. In our class, usually it's a 2-digit number. Every now and then it'll be a 3-digit, every now and then it'll be a single digit, but most of the time it is a 2-digit number. Alright, so find your formula chart. Hopefully you've printed this. If you haven't, go ahead and print your tables and formula card. We talked about how we're going to number the pages 1 through 8. And I want you to turn to page 5. And it says random numbers at the top, table 1. And again, I numbered it by hand. You can just label this page 5 so that when I say page 5, you'll know what page I'm talking about. And we're going to just kind of look at how this random number table is set up. Again, it is a little weird if you've never seen it before. So I'm just going to kind of go over some key points here. You don't have to write on yours. You can just kind of follow mine. Notice down the left you have row numbers. So this is row number 1, row number 2, row number 3, all the way across these row numbers. And they're kind of blocked in gray and light gray and dark gray. Those are just to help you follow where you are. That doesn't mean anything as far as anything. It's just all the same table. It's just these shaded regions kind of help your eyes follow along the values. The column numbers are a little confusing. Each column is a single digit. So column 1 is the 8, 6, 1, 2, 3, all the way down single digits. Column 2 is the one right next to that. Column 3 is in the middle, the 3, 4, 4, 5, 8, all the way down. Column 4, and then column 5 is that last digit. So this is columns 1 through 5 as single digits going down. Column 6 is again right next to it. Technically speaking, these are all smashed together. So if you see older textbooks, all of these are smashed together. This textbook just puts a little bit of space every 5th column to help your eyes. So technically speaking, again, these are all squished together. So this 2 and this 2 are right next to each other. They just put a space to help you follow the numbers. Otherwise, you can get a little lost in all these values. So wherever you start, you always go down the column. So they're going to give you a row and a column to start at. So wherever you start, you always go down. When you get to the bottom of a column, you go all the way to the top of the next column and go down. When you get to the bottom, all the way up to the next and go down. So if it tells you to start on row 11, you start on row 11, you go down. When you get to the bottom, you go all the way back up to the top, back to row 1 every time. So it's kind of like a typewriter, if you guys remember those. Wherever you start, once you hit the bottom, it jogs all the way back up to the top. So that's just some technicalities here. We can read these as single digits, like 8, 6, 1, 2, 3. We can read these as double digits, 89, 61, 11, 27, 36. We can read these as triple digits, 893, 614, 114. So you can read them 1 at a time, 2 at a time, 3 at a time, depending on your frame. So, looking at our frame, these are all 2-digit numbers. So we're going to start on row 1, column 1, looking at the digits 2 at a time. So if I look at the digit 89, 89 is not in my frame. My biggest number is 30, so I'm going to ignore 89. 61, not in my frame. I'm going to ignore 61. 11, the 1, 1, is in my frame. So that's the first company I'm going to pick, is company number 11. Going down, 27 is in my frame. That's the second company I've chosen. So it's kind of like drawing names out of a hat, right? We draw a name, they're not there. Okay, next name, they're not there. Okay, next name, okay, they're there. They get chosen. So you're just like drawing numbers out of a hat. The next one we draw is 36, not in the frame, so we ignore it. 81, not in the frame, so we ignore it. And we keep looking 2 digits at a time until we find the one we want. So the next one that's valid is 24, I think. Let me just double check. Yep, 24. So that's the third. And we keep going until we have the number they want. They want 5 in the sample, so we're going to keep doing this until we have 5 good numbers. So 98's no good. 14 is good. So 14 is the fourth. Going. 55's no good. 96, no good. I just keep going. And the last one I would pick is 10. And I know that that's my last one because that is my 5th choice, and I need a sample of 5. If I needed a sample of 10, I would keep going. I would keep going and keep going. If I got down and needed more, so if I was at 67 and I needed more, I'd go all the way to the top, and my next number was 39. If I get to the bottom of that set, and I'm at the 41 here, and needed another set, my next number would be 22. So again, you jump right across that space, and those numbers are stuck together. So again, little confusing. I don't want to over-explain it here, but if you have any troubles with that in the homework, let me know, because it is a little tricky. So our sample of 5 was the Fox Studios, and then the Ultimate Electric. Then we chose the Spruce Landscaping, and then John's Bakery, and then the First Fifth Bank. So the homework wants you to put the results in the order they were chosen, and they sometimes want the numbers in the order they were chosen or the names in the order they were chosen. So I know that can be a little tricky sometimes. So this is kind of your guide of how many to go by. Go by 2s is the most common. Sometimes we can go by 1s, sometimes we can go by 3s. So let's do another example. We want a sample size of 3 from the following population. There's only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 names. So your frame can start at 0. 0 is a valid number here. 5, 6, 7, 8, and 9. So we can use single digits. And they're usually numbered for you in the homework. This one example, they weren't numbered. But let's all number them the same, 0 through 4, 5 through 9. And that way we can just use single digits. Let's start at row 11, column 16. So your homework will specify where to start. Sometimes in the homework it will have just a piece of the random digit table that you click on and it just pops up on the computer, and you'll just use whatever piece they give you. So it kind of depends on what they're asking. Sometimes it'll tell you where to start. Sometimes it'll just give you a piece of the table and you use the piece they gave you. Alright, so if we're going to start on row 11, column 16, here's row 11, column 16, going with single digits. The first number is 0. So my first choice was 0. My second choice going down from there would be 1, and my next choice would be 9. If there's a repeat, like if there's another 9, you just ignore it. And you just keep going until you have 3 unique choices. So our second choice was number 1, and our third choice was number 9. So the choices will vary based on where you start, and it will clarify in the problem where to start, and you always work down. So Maddie was our first choice, Evan was our second, and Jordan was our third. And again, it wants your answer in the order it was chosen. So a note at the bottom, an SRS can also be obtained by placing each member of the frame on a separate piece of paper, putting them in a hat or bag, and drawing members without looking. So if you've ever been to a raffle where they throw all the tickets in the bucket and you randomly draw a ticket, it's the same idea. We're numbering everybody. It's kind of like everybody gets a ticket, and then we draw tickets using the random digit table. And that tells us who won the survey, whoever gets chosen to be in the sample. All right, I'm going to stop there, and then we'll continue with other types of sampling.